Okay, we are looking in this video or learning how to find the surface area and volume of prisms with a regular polygon for its base. As we've stated up here at the top of the page, the prisms in this section will have a regular polygon as their base. We've already completed problems involving prisms whose bases were equilateral triangles, squares, and regular hexagons. In this section, we learn how to find the surface area and volume of prisms whose bases are regular pentagons, regular octagons, etc. The same surface area and volume formulas that have been previously used will be used in this section as well. Those are: the surface area is equal to 2 times the area of the base plus the perimeter of the base times the height of the solid, and the volume is equal to the area of the base times the height. In this case, we are given a pentagonal prism. The base of the prism is a regular polygon as it's stated in the directions. So in this case, let's start by drawing our pentagon separately. In fact, I'm not going to draw the whole pentagon. Let's just draw the triangle. And remember, the triangle we're referring to is the triangle formed by the center of the polygon, the center of the pentagon in this case, and 2 radii, which are congruent, where this base here represents the side of the pentagon. And in this problem, we are given the radius length as 7 feet. So this is going to be 7 feet long, and this will be 7 feet long as well. The other thing that we'll need to know is the measure of this central angle, and we find the measure of that central angle by taking 360 degrees and dividing it by the number of sides on the polygon. In this case, we are looking at the sides on a pentagon, so we divide by 5. That gives us a 72-degree angle. And that, and keep in mind, is here between the 2 radii. All right, in order to find the area of the base and the perimeter of the base, we have to be able to determine this particular length. We also have to know, in order to find the area of this regular polygon, we have to know the length of the apothem. Now, when we draw the apothem into this triangle, which forms the height of the triangle, that apothem A divides that 72-degree angle into 2 congruent parts. So 72 degrees divided by 2 tells us that each of these angles will measure 36 degrees. All right, now notice position-wise. I need to know the length of the apothem in order to find the area of the polygon. I also need to know the length of this shorter side. We're going to call that x for the time being, so that we can determine the length of the side of the polygon, which in turn will give us the perimeter of the polygon itself. For that reason, knowing that I need to find both of those, and that the 7, which is the hypotenuse of this right triangle, is given, tells me that I'll need to use the sine function in order to find the length of x, and a cosine function in order to find the value of a. So we'll set up those 2 functions. The sine of 36 degrees is the opposite over the hypotenuse, x over 7. When we multiply both sides by 7, that produces 7 times the sine of 36 equals x. So if this portion of the side of the triangle is 7 sine 36, doubling that will tell us that the side of the polygon, in this case the pentagon, would be 14 sine 36. And remember, when you double that length, you're doubling the 7, not the angle measure. If the side of the pentagon is 14 sine 36, then the perimeter of the pentagon would be 5 times that value, or 70 sine 36. And that's our capital P value that we need in order to determine the surface area. Okay, so back to our problem. We need A as well. A is the adjacent side to the 36-degree angle. 7 is the hypotenuse. So adjacent and a hypotenuse indicate a cosine function. In this case, once the cosine function is set up, in order to find the value of A, we multiply both sides by 7. So in this case, that's going to produce 7 times the cosine of 36 equals A, which is the apothem. Once we have the perimeter and the apothem, we're ready to find the area of the pentagon. So the area of the regular pentagon is 1/2 times A, 7 cosine 36, times P, 70 sine 36. As we know with these sine and cosine values, it's going to produce a never-ending decimal for these particular functions, or these particular angles. So I'm going to leave it in that form. We could go ahead and simplify that a little bit. You do 1/2 of 70 is 35, and 35 times 7 is 245. So if we wanted to, we could rewrite that as 245 cosine 36 sine 36 degrees. Not that it's much shorter, but it is a little bit more condensed, I suppose. Okay, so at this point we have the area of the base, we have the perimeter of the base. The other thing that we need is the height of the solid. And remember, the height of the solid is the distance between these two pentagons, which is over here, this 10 feet that we were originally given in the problem. Let's get that bar up there at the top out of the way so we can see our 10-foot section here. All right, so with that in mind, let's start finding the surface area. Surface area is 2 times the area of the base. Definitely want to leave yourself some room to write on these. Plus the perimeter of the base, 70 sine 36, times the height of the solid, 10. And now some button pushing. 2 times 245 cosine 36. Don't forget to close your parenthesis after the 36. Likewise, do the same when you close the parenthesis for the sine 36. Close the parentheses again here, times 10. 644.46 feet squared. Now let's look at the volume. The volume is equal to the area of the base times the height of the solid, 10. Which gives us a value of 1,165 4/100 feet cubed, since it's a volume. So you can see that these problems can take not only a lot of space, but they can take some time, and they provide a lot of opportunities for mistakes to be made. So you have to be cautious in your work.